Hello, welcome to your first lesson on calculus. This is the stuff you've been waiting for. Now, there's lots of people who in italics invented calculus. There was lots of people working on the same problem at the same time in different parts of the world, and they didn't have the internet to converse with each other or do things very quickly, so it took a while to realise that they were working on the same things. But the main people we know that we attribute this to is Sir Isaac Newton and Gottfried Leibniz. Now, because they were both working on the same problem at the same time, it doesn't mean that they were using the same mathematical notation. So what you will find when you're doing calculus is that depending on what textbook you're using or what you're referring to, there will be different notation for the same thing. And we'll talk about that more as we go through the topic. So two of the biggest problems facing mathematicians in the 17th century were how to find the tangent to a curve and how to find the area under a curve. Eventually they realised that these two are linked, and this led to the fundamental theorem of calculus, which we will get to. And as I've said here, there are different notations that sometimes mean the same thing. Let's focus on this idea of a tangent. We haven't seen a lot of tangents. We've mainly seen tangents when we've been talking about circles. So I've got a circle here, and if I wanted to construct a tangent to it, I would get my ruler. So I would say insert, no, I would draw, and I would get a ruler. And I can draw a tangent anywhere on to this circle. Remember, a tangent is a line which just touches the edge of the circle, and that's our main exposure to tangents so far. So it will touch, it doesn't cut it, but it just touches in one spot. And what we learned about tangents in year 10 maths was that if we draw a radius from the centre of the circle to the point where the tangent meets the circle, that we always get a right angle. And those of you doing specialist maths will have seen that again this year, or you're about to. So we don't need that information, but it's kind of cool to remember that. But we do need to think of this idea of a tangent of just touching but not cutting. So it's only got one point of intersection or where it touches for that circle. So the other thing we have to say is, why do you want to find a tangent to a circle or to a curve or to something else? So I want to give you a real life example. Let's say I can run 2 meters every second. And if I wanted to graph that up, this is what it would look like. It would look like the graph of y equals 2x. So my speed or my run rate is constant at 2 meters per second, and this is directly related to the gradient of the line, because we know y equals mx, the gradient of that line is 2. Now, I'm not that consistent a runner, so let's say my running looks a bit more like this. Say that my run rate is going to change according to where I am on my run. So if I want to know what my rate of speed, my rate of running is at any point in time, I would have to say at that point, so what's happening when time is equal to 3 seconds, I would have to find the gradient of the tangent at that point. So I'd get my ruler and I'd say wherever that tangent is, so that it just touches that curve, I'd have to find the gradient of that line there, and that would tell me my rate of running at that instant. Okay, but it would be different to my rate of running here. Up here, I'd have to get my ruler, and I could see that my rate is higher. I'm faster there, so the gradient of that line is going to be different. So our problem now becomes, how do we find this tangent? Let's go and investigate that. So to construct a tangent, because I've just done it roughly using my rule there, but normally if we want a straight line, we want to find the equation of these straight lines, we're going to need 2 points, or we need to know the point and the gradient of the tangent. Now, we don't know those things yet. So here's how we go about finding what we think is going to be the gradient of these tangents. It says here to draw y equals x squared plus 3x with lots of space. Now there's not lots of space on this sheet here, so I'm going to go to a new page and I'm going to draw up y equals x squared plus 3x, and you might like to do this on your piece of paper as well. So I've got myself a sheet ready here. I'm going to have a look at y equals x squared plus 3x. Now we should be pretty good at graphing things like this. We think of that as being x plus 3, which we know is a parabola, and this parabola cuts at 0 and at -3, and concave up, and this, and that's what it looks like. We've got our x-axis here and our y-axis here. Now let's say that I want to choose the point, this point here, where x is equal to 1. Now when x is equal to 1, y is equal to, well, let's put it into here, it's equal to 1 squared plus 3, which is 4. So this is actually the point 1, 4. So let's say I would like to find the gradient of the tangent at that point. So I'm thinking about the idea of getting my ruler and being able to draw a tangent at this point here, and I want to find the gradient of that straight line. How am I going to do it? Well, what I'm going to do is I'm going to get my handy little magnifying glass here, and I'm going to try and have a look a little bit closer at what's happening around this point here. So I'm going to draw it again, but I'm going to exaggerate things because I'm going to imagine that I've got my magnifying glass on it. So here it is again. I've got my y-axis, I've got my x-axis, and I'm honing right in on the point. Green pen gone. I'm just going to have a look at this section where I've got the point 1, 4. Okay, so this is 0, 0, and I just want, because ultimately there's the rest of the parabola. That goes down to there, comes up somewhere else, but I'm just interested in this part of the parabola, and I want to find the tangent here. Now, to find the equation of a line, and this goes back to year 10 work, if you want to find the equation of a line or even the gradient of the line, you need to know 2 points. And we don't know 2 points, we only know 1 point. We know the point 1, 4. Let's say I make up a line that's going to give me really, really roughly, it's going to give me some kind of estimation of the tangent. So let's say I say, what happens if I find the equation of this line? I don't even need the equation of it, do I? I just need to find the gradient of it. So it doesn't look like it's going to be very useful, but remember, my magnifying glass is on this. So if I look at my picture up here, I say, well, that's my tangent that I'm looking to find. Let's say I can find this one, because I'll be close. I won't be really close, but I'll be on the right track. Now you will remember, I hope, from year 10 that when you're finding the gradient of the line, we're looking at the rise over the run, or we use the formula y2 minus y1 on x2 minus x1. So that's what we remember from year 10 about finding the gradient. So let's find the gradient of the line between these 2 points. So we're going to go between 1, 4 and 0, 0. I'm going to call this x2, y2, x1, y1. So the formula for the gradient is going to be 4 minus 0 on 1 minus 0, which is equal to 4. So the gradient of this line is equal to 4. Now I think you'll agree that that's not really going to help us find the gradient of the tangent too much. So maybe I'll go a little bit closer. Maybe I'll go to 0.5 on the x-axis. And maybe I'll find the gradient of that line. So that's going to be from here That's definitely going to give me a better estimate. So the tangent that I want to find is this one that's here. I want to find. So I'm going to instead try and find this one. So a ruler, and I'm going to try and find the gradient between these 2 points. Right, so I'm going to find the light blue one. All right, well, this point here, I need to find what it is first of all. So this is the point 0.5, and to find the y coordinate, I have to put that into the formula for the parabola, which remember was y equals x squared plus 3x. So on my calculator, I will put in 0.5 squared plus 3 times 0.5, 1.75. Right, so now I've got 2 points that I'm trying to find gradient between. So I'm going to do m is equal to, well, this time it's going to be y2 minus y1 on x2 minus x1. And my points this time, I'm still going to use 1, 4, and that'll be my x2, y2. And this time it's going to be between 0.5 and 1.75. So when I use that, that'll be my x1 and my y1. So when I do that, I've now got 4 minus 1.75 over 1 minus 0.5. I do that on my calculator. Minus 1.75 divided by, and I get 4.5. So the blue line has got gradient m equals 4.5. Now I'm sure you will agree that I could go much closer to the point 1, 4 and get a better approximate for the gradient. So let's go to 0.9. I need some new colour. Try orange. So this time I'm going to go to 0.9. And that will get me to this point here. It's getting a little bit messier, but that's going to be the point 0.9. I need to find a y coordinate that goes with that, so I'm going to put 0.9 into the equation. Into the equation y equals x squared plus 3x. You might like to pause and do that on your calculator, or you might be quicker than me. 0.9 squared plus 3 times 0.9 equals 3.51. So now I'm going to find the gradient of the tangent between that point and 1, 4. So I'm getting a lot closer to the tangent that I'm interested in. So this time we've got m equals y2 minus y1 on x2 minus x1. And it's between the point 1, 4 and the point 0.9, 3.5. I'd like you to finish this. I'd also like you to go even closer to 1. I'd like you to go to, so we're doing 0.9, I'd like you to go to 0.99, 0.999. And if I just flick back to my previous page, we're filling out this, we're going to do 0.9999 as well. 0.9999. So pause the video and go away, and I would like you to find the values for the gradient of the tangent as this x value gets closer and closer to 1. And you should notice something really nice happening to your pattern. So pause the video, you've got some calculations to do. You're going to keep finding the appropriate y or the associated y value for each of these, and then you're going to use the formula m equals y2 minus y1 on x2 minus x1 to find the gradient of the tangent between those 2 points, and you're going to hopefully see a pattern. You might like to put your answers into a table like this. So pause the video, do that, and then let's come back together. All right, well, I hope you saw that that was just getting closer and closer to 5. So as the value of x approaches 1, the gradient approaches 5. So it looks like the limit will be 5, but how do we know for sure? Well, we're going to get there. But for now, I just wanted you to see this process of taking values closer and closer to the point where we want to find the tangent so that we can actually find the gradient of the tangent at a point. So what we're aiming to do is to find we will be spending some time finding the equation of this tangent, but at the moment we just want to find the gradient of that tangent because that will tell us exactly what's happening at that point. So that's the end of this video, but once you've finished that, we'll move on to the next videos. You will need your graphics calculator ready and handy for the next video. Thanks everybody.